Yes, in the previous videos we have discussed about the problems on the trains. Okay, distance between problems on the trapezoidal and quadrilateral speed time curves we have discussed in the previous session. In this session we'll discuss some of the problems on the electric traction, that is tractive effort and coefficient of adhesion. Okay, so let me start with the first example. An electric train weighing 300 ton has 12 motors geared to driving the wheels. Each wheel has a diameter of 100 centimeter and the train has to be accelerated at your 60 kilometers per hour in 30 seconds up gradient of 1 in 100. The train resistance is 40 newtons per ton. The effective of rotational inertia is 10%. The gear ratio is 4. Gear efficiency is about 80%. Determine the torque developed by the motor. Okay, you have to develop the torque developed by the motor. So from the derivations which we have solved in the previous section, so alpha is equal to Vm divided by T1. So Vm you know, so T1 is now, so Vm divided by T1 is 30 seconds, so it will get 2 kilometers per hour per second. So gradient factor is once again, so G is equal to 100 sin theta. How to calculate this one? Gradient is equal to 100 sin theta. 100 sin theta is 1 in 100 that have. So the gradient is 1 in 100 they have given. 100 into 1 in 100, you will get gradient of 1%. Okay, you know the equation for the tractive effort. So Ft is equal to 1 this we have solved in the previous video. So 277.8 We alpha 98.1 Wg plus Wr. Okay, so using this equation, substitute W is the dead weight of the this one and its actual weight, which is the gravitational, R is the rotational inertia. Okay, so substitute all the parameters in this equation, all are given here. We weight of this one, okay, just observe here. So it is 300 ton. Okay, everything is given, just to substitute here and calculate Ft. It is 2,24,778 Newton you will get. Okay, so just Ft, you just remember this one. Now another equation to calculate the tractive effort Ft is 2 into F into gamma divided by Ta divided by d. So from this you calculate the torque developed here. So Ta is the torque developed, d known, gamma everything is known. Substitute all the value. So Ft is calculated here from this equation. So 2 efficiency 80%, gamma is they have given your 4. So Ta divided by d, d is the distance, it's 1 kilometer. Okay, now substitute all the parameters and calculate for T. You will get T is equal to 35,121.56 Newton meter. Okay, this is a total torque developed by the motor. Total torque developed by, so they are telling here 12 motors are there. So they are telling in the question there are 12 motors. So it is a total torque developed by. So the torque developed by each motor you have to find out. See here, you read, see here it's given. Torque developed by each motor you have to find out. So total is 12 motors are there. So total torque is this much. So if you divide this one, you will get the torque developed by each motor is 2926.8 Newton meter. Okay, that is the torque. Similarly, next question. So 300 ton motor coach is driving by 6 motor, each developing a torque of 6000 Newton meter during the acceleration. Starts from the rest. The gradient is of around 40 in 1000. The gear ratio is 4 and the gear efficiency is 90%. So when radius is 50 centimeter and the rotational inertia is 12%, the train resistance is 40 Newton per ton. Calculate the time taken by the train to attain speed of 60 kilometers per hour if the DC voltage applied to 3000 volts and the more efficiency is around 86%. So find the current drawn during the notching period. Okay, so torque developed by the motor is 6000 developed by each motor. There are 6 motors, so the total torque developed is 6000 into 6, so it is 36,000 Newton meter. Okay, so gradient factor it is once again they are given 30, right? Okay, 40 they have given, you just take it 30 only you can take. So 40 it is not 40, 30 only you take. So gradient factor 100 sin theta, 100 into 30 divided by 1000, so you'll get it is 0.3%. So We is 300 is the dead weight into your, yes, just a minute, Okay, W is 300 into 1.112 is constant, so you'll get this one. W is 336 tons. So D is equal to 100 centimeter there again, it's equal to 1 meter. So Ft is known equation. Okay, so from this you just substitute all the values. Okay, and you will get Ft is equal to some 2,59,200 Newton is the tractive effort. So you know equation, one more equation to calculate the tractive effort. So this is the equation. Just substitute all the parameters. Ft is calculated. So substitute all the parameters and calculate the alpha, acceleration alpha. So now the time taken to attain the speed of 60 km is given by, so T1 is equal to Vm by alpha from the derivation. So Vm is 60 divided by alpha is find it out. So substitute, it is 35.23 seconds. So the power output at the driving axle is, it is the equation, you just refer to the tractive effort derivation. So you'll get this equation. So substitute all these values here and calculate the power. Power driving to the axle wheel is 4320 kilowatt. Okay, so power input is equal to, so the output is, the efficiency is equal to output by input. So input is equal to output divided by efficiency. So power output is 4330 divided by efficiency given in the problem 0.86. Okay, 86%, 0.86. So you'll get the power input here. Power input is around 5032.26 kilowatt. Okay, so the current run is equal to P is equal to VI. So P is equal to VI. So I is equal to P divided by V. P is how you calculated here, divided by V is 3000 volts. So substitute, you will get the current drawn is 1677.42 amps is the current drawn. Okay, that is the problem. So next is another equation, another problem. Yes, we'll discuss another problem here. Current drawn is here. Okay, next problem. The train weighing 200 tons is moving up in a gradient of 3% at the speed of 45 kilometers. 45 kilometers per hour. The train resistance is 2.5 kg per ton. The supply voltage of 2000 volts, the DC, and the combined efficiency of the gear and the motor is 85%. The effect of rotational inertia is around 10%. So if the power is cut off, find the time taken by the train to come to rest on its own. Find also the current drawn before the power off. Okay, here, so let us, the coasting retardation beta C when the power off, when the power is cut off. When the power is cut off, Ft is equal to 0. Okay, so that is tractive effort is 0. You know the equation. So Ft is equal to, this is the equation. So they are given a retardation here, that is you can take it as minus beta C instead of alpha. Okay, just Ft is 0, power is cut off, Ft is 0. So just kind of find out the beta C from this equation, substitute all other findings, all other values, and substitute, find out is, so beta C is equal to 1.043 kilometers per hour per second. So time taken to come to the rest. So from the derivation part, so it is T is equal to V1 minus V2 divided by beta C. V1 is 45 speed, so it is 0 divided by beta C is calculated. So the time taken to come to the rest is 43.15 seconds here. So when the train is moving up gradient, what is the this one? So when the train is moving in the up gradient, there is a absence of your dead weight. So Ft is equal to 98.1 into Wg plus Wr. So 98.1 into Wg is 200. So gravitational W is 200. Okay, into R is 3. So here W 300 into gravitational force 9.18. So substitute, you will get Ft is equal to 63,765 newtons. So the power output at an axial is Ft. This is the equation which we have derived from the previous this one. So Ft into V divided by 3600 kilowatt. So Ft and V you substitute, so 3600 as it is, you will get the power output axial is 797.6 kilowatt. Okay, so power input is once again from the efficiency is equal to output by input. So from that you will get the power input, it's equal to P is equal to VI. So substitute power here. Okay, efficiency, you will get the power input. Okay, so current run, is P is equal to VI formula. So here if you want to calculate the current, P divided by V, you will get the current is 468.86 ampere. Okay, this is the similar to that of the previous problem which we have solved. Okay, next is similar kind of problems you may get in the exams, just to go through that. So if you have any doubts, you can contact me. Okay, thank you.